Uh, good afternoon to you all. Uh, all colleagues of the department, head to this Professor I.M. Fernandez and all the other colleagues, my batchmate, Professor Tiki, and my husband, my batchmate Bhagavath, Dr. and dear sons and daughters. Now, you all know the topic of today's lecture or discussion. We can have a discussion at the end. So, this is the first medical cyclotron, for that matter, any cyclotron, because in nuclear physics, we talk about cyclotrons, research reactors, nuclear reactors, power reactors, and so on. So, as you all know that still we don't have any, even a research reactor. So this may be the first step forward towards achieving that goal. So it's a cyclotron, and we teach the cyclotron, principle of cyclotron to university students, even A-level students, because this physics principle is very simple. Okay, so let me give you a brief idea about the cancer situation in Sri Lanka. This I got it from somewhere. As you all know, in Sri Lanka, I mean, most of the people now they say that having some sort of a cancer. 29,600 new cases and 16,000 something death recorded in 2021. So this data gathered from 2021 and a projected 23% annual increase through 2030. So that's a big health risk. I don't know the reasons. Maybe our food patterns or stress from I don't know. But there's an alarming increase of even young people. So this is a serious situation. So historically, now remember this PET scans and the FDGs, as we call it, provide glucose. This is not a cure for cancer, but it's a diagnosis. You can diagnose this if you have a cancer at the early stages. So the landscape, or normally people use fluorine 18, coupled with glucose. I will talk about it later. So fluorine 18 is a beta plus emitter or positron emitter, as all science students know. So far we have to get this drug FDG from India, because we don't produce it in Sri Lanka. Actually, we have 3 PET scanners in the country, one at Apeksha Hospital, one at National Hospital, and RCD has another one, it's a private. I think Health Hospital PET scan is, as I understand, is not functioning properly. Even if you have PET scanners, PET scanners came into Sri Lanka some 20, maybe 15 years back. But even though you have PET scanners, if you don't have this radioactive drug, you can't use it. So it's like people say, because you have to have the drug, otherwise you can't get the scanner. So this FDG, normally you get it from India, but there's a big hitch here. The half-life of fluorine is less than 2 hours. So anyway, as a radioactive pharmaceutical or radioactive drug, half-life 2 hours is very good, because nobody inject long half-lives into our body, because that is even problem for the others, because you are having that drug inside your body and you are emitting radiation, and that will affect the people around you also. And on the other hand, if the half-life is very, very short also, that is also not efficiently, you can't use it. Because if it is very, very short, once you inject the drug, within a very short time, it decays. So 2 hours is a very, very acceptable half-life for a radioactive pharmaceutical. But on the other hand, since you are getting it from India, it takes time. So once it comes to Sri Lanka, it's about 97% decays. So the government has to buy a large quantity in order to cover that decay loss. For a patient, you need around 10 millicurie. It depends on the weight of the patient. It goes into mass. Anyway, roughly you need 10 millicurie. So normally what happens is in Apeksha hospital, they do it only once in a week, only for 10 patients. Because once you get this from India, 97% decay, so you have only small amount of activity or the dose for the patient to be injected. So and sometimes some weeks patients have already prepared and they are ready to take the drug, but the shipment won't come. Because even if you now even these radioactive things, you have to have a license. So even for a pilot to take this drug to Sri Lanka, pilot needs a special permit, permission or some sort of written document in order to say that he is capable of, he has the authority to bring it to other countries because radioactive things. Now people have a lot of rules and regulations. You can't just ship like that. So because of all these things, actually, even though you have PET scanners in the country, we had a big issue. So what the oncologist says, you need 35,000 PET CT scans. Now the trend is you take PET and CT both together. Of these modern PET scanners, they have CT also, computer tomography. CT also, you can get very good diagnosis if you use both PET as well as CT. So, so you can see there's a huge backlog. Even doctors or oncologists prescribe to take a PET scan. The patient can't get it because even if the nursing hospital got 3.5 lakhs for a one PET scan. So due to this, actually, because of this, when I took over as the chairman in 2020, I had taken the board. The project was initiated, but nothing happened actually. Because you need the government support. Actually, at that time, people thought you had to get all the money from the government. So when I became the chairman, I took this project as of my own project and try to somehow develop this facility, cyclotron facility in Sri Lanka. At the beginning, we thought of getting money from the government, but 2021, because of the economic crisis and all this COVID, we couldn't get even a bank guarantee for public funds. So even we visited cancer hospital, and even the cancer hospital, if we had the cyclotron at the cancer hospital, it is very easy because the decay loss is very less. Now, Singapore, some hospitals they have the cyclotron within the premises of the hospital itself. But when we went and checked, actually there was no room for it. Then we wanted to go to KDU, but that also we had because we found out that the land does not belong to Colombo University. So so we got stuck. We want to raise funds, but the time was not good. Then we thought of going with public-private partnership. That was the turning point actually. So we called for proposals. 3 companies submitted, and we selected one. The cabinet of ministers approved to go as a public-private partnership. So those have build own operate called the BOO module. I learned all these things because I became the chairman because these things we didn't know. We were academics, not probably. Working with government departments is very difficult because they have all sorts of rules. They are not even, if you look at one circular, other circular concurrence. So anyway, now it's a 6.5 million US dollar project. So government is not giving any funds. So we made sure that we signed an agreement. All the funds come from the private party. Actually, the private party is Access International, Access as. Now we have formed another company called Access Medical Tracers. Access Medical Tracers in collaboration with the Academic Board and Health Ministry. So even though government is not spending any money, 80% shares goes to them and 10% shares come to Sri Lanka Academic Board, and Ministry of Health also get another 10% without siphoning or without providing any money. So that is also online. And apart from that, when they sell, if they sell FDG for private sector, Academic Board gets 2.2%. So this is how it works. Now, if you come back to this, this has a lot of physics, chemistry, biology, biotechnology, and everything. I am not familiar with biology and chemistry, but we have experts. Maybe this is wrong, but I am not used to this. This is glucose. This is a normal glucose molecule. FPG means to replace one OH block from fluorine. So this fluorine 18 is the beta plus emitter. So we need the cyclotron to produce this fluorine 18. So it goes, I think this is at the second phase. 1, 2, 3, 4, I think chemists know about these things. I'm not so familiar. So this is what we call this FTG, fluorodiazid glucose. But later I realized actually they don't use the glucose molecule. They use something called the mannose or something. I will come to that later on. Because I was thinking now how come only this place is eliminated like other OH parts all over the place. But how come only the second carbon atom gets the fluorine 18? So always as physicists we want to find out the reasons. So then I realized actually they are not using at the beginning the glucose molecule but something else. I will come to that later on. Anyway, this is what is injected to the patient. So glucose is a nice molecule. As you all know, cancer cells need energy. Cancer cells look for energy, right? So even sugar, we all like no sugar. Even cells like sugar. So cancer cells, think they are looking for energy because they have to develop or they have to increase their number. Glucose is readily absorbed. Readily absorbed because cancer cells like glucose because they have the very power thing that will be there. Okay, so then now we want to produce fluorine 18. That's where we need the cyclotron. Because it is a nuclear reaction, so you have to bombard protons onto oxygen, oxygen 18. And this is the nuclear reaction, proton onto oxygen 18 to get neutrons, and the fluorine 18 is the product. So we have a threshold, in nuclear reactions, we need the light chemical like biological reaction. You have to pump energy at the first most of the time. So we need about 16 MeV protons in order to get this reaction going. So I always, when I teach the students, I always say nuclear reactions are very, very simple to learn. Unlike biology and chemistry reactions, huge molecules, helium, that this. These nuclear reactions are very much, it's very simple. You have to just conserve with number and then nothing else. So, learning nuclear reactions are, for me, 1,000 times easier than going with biology and chemical reactions. I know there are a lot of biologists and chemists, they might not agree with me. But we don't have these big molecules to comprehend. These are very simple reactions. So now we need this is the target, this is the liquid target. Actually, we have to get this water really. In water you have oxygen 16. But there is something called oxygen 18 rich water. It's I think about 1 gram is around $100 or something like that. So we have to get this oxygen 18 rich water. Normally, I don't remember the percentage of oxygen 16 to oxygen 18. There are some small amount of oxygen 18, but that is not sufficient. So you have to have oxygen 18. So people call it heavy water. It's not really heavy water. No, normally heavy water means you have deuterium. Normal water is H2O, but hydrogen you have three isotopes, deuterium and tritium. Tritium is radioactive. So we call heavy water means with except without hydrogen you have deuterium. But when you have oxygen 18 enriched, you call it heavy water with oxygen 18. So this is a simple reaction. So we need the cyclotron to accelerate protons and bombard into water, and you make fluorine. So it's a very simple nuclear reaction, and in turn fluorine decays by emitting positrons. That's the pitch, positrons. It's a beta plus emitter. So this is the decay scheme of fluorine 18. Beta plus emitter, you have not cancel. So this is the important part. As you all know, as physics students, when you have positrons, they are an antiparticle, right? Positive electron, positron. When positron meets electrons, we always teach the students, it's called the matter is converted into energy. That's the way, that's the only reaction that you can convert all the mass into energy. There's no other reaction scientists have found in the universe where matter is converted to energy 100%. So when electron meets positrons, that is matter with antimatter, they annihilate. We call it annihilation, pair annihilation. So we teach this to our first year students. Pair annihilation and pair creation is the reverse. So then you get two gamma rays. So the gamma rays can be, easily detectable. There are gamma cameras. Gamma rays, detection of gamma rays is nothing, peanuts. So this is where this fluorine 18 is very important because the beta plus emitter. We have a lot of electrons in the body. And this is also. So when positron meets the electron, they annihilate. And you get two gamma rays. Two also good because then the oncologist can pinpoint where they came from. If it is only one photon, it's difficult to find out where they came from. So if there are two photons going back to back, just to conserve momentum, linear momentum. This is the mechanism behind FDGs. Glucose, you have fluorine 18, glucose cells like glucose. Then once get absorbed, you have pair annihilation, and you get gamma ray. So this is the PET scanner. So you can see that you get two gamma rays. So they can reconstruct these parts on a computer and find out where the problem is. Getting two gamma rays is also very, very crucial. So this is the simple principle behind physics principle behind PET scanners. We have an array of array of detectors. Once these annihilate, you get two gamma rays. So you can backtrack them and find out where the problem is. Then we come to the physics part now. So I am familiar with a lot of physics part, not the chemistry and biology, but I will touch on that. But if you have any questions, chemistry and biology, there are experts in the audience. So the cyclotron-based is also very, very simple. Even we teach this to level students. So when you have a charged particle in a constant magnetic field, there is a force called the Lorentz force, PVD, Q is the charge, and it's whether it means square of R. That's very simple relationship. Right? So our science students know this. QV is the force, magnetic force, FV square to R. So R is equal to mv over QV. And time for one revolution is 2 pi R over V. So T equals 2 pi m over QV, frequency is 1 over T. It's simple mathematics and physics. So this is known as the cyclotron frequency. Now, the important thing is here, the cyclotron frequency does not depend on the radius. That is the turning point. Frequency, because cyclotron frequency does not depend on the radius. That physically also we can understand that if the charged particle is traveling in a smaller circle, speed is less, circumference is the length of the circumference is also less. But if the speed becomes larger, you have to travel long distance with a high speed, so time is same. So frequency is we are able to substitute this goes into the radio frequency region. So therefore, this is the simple physics behind the cyclotron frequency. But as you know, when you accelerate, to accelerate the charged particle, you need the electric field. That also we teach the students. Using a constant magnetic field, you can't change the speed of a charged particle because this is a force towards the center. So the speed increases as you go on, but once these are called Ds, these are two Ds, called the evacuated chamber and called the Ds. So once the charged particle crosses this gap, you have to apply electric field because you have to do a push. So here what happens is if a charged particle travels from here to here, let us say it's a proton. Now if the charged particle travels from here to here, this should be negative and this should be positive polarity because positive attracts negative, positive repels. So you get a kick. But once the charged particle comes over here, you have to change the polarity of the D. You have to keep the same thing, you decelerate once you cross the gap. So as soon as the charged particle comes over here, this has to be the polarity has to be changed, positive or negative, or negative to positive. So that is why the cyclotron frequency does not depend on the radius. Therefore, you can have the same switching frequency throughout because whether the charged particle is going around a larger circumference or larger radius or smaller radius, frequency is same. So you have to keep on changing the positive and negative. Because once we take proton, this should be negative. This once it comes here, if it still has negative and positive, this decelerate. Then this should be negative and this should be positive. So this is the simple principle behind the cyclotron. So as long as the mass is constant, this is true. If you have learned relativity, you know, if you go relativistic speed, mass becomes inertia becomes large, so the frequency changes. So in that situation, if you want to have the same frequency, you have to change the field also to have the same frequency because you don't want this frequency to be vary because technically it's difficult. But if you have same frequency rotation or changes, you can have the frequency changes throughout. So as if M increases, now for this 18 MeV, it won't happen. But if you want to accelerate to say 200 MeV or so, mass increases. So when mass increases, cyclotron frequency decreases. So you can go away with that by changing B. If you keep on changing B as the dark particle crossover, you can have still the same frequency. That is called synchrocyclotron. Synchrocyclotron. Right? On the other hand, some cyclotrons are there as to increase the speed, radius increases. But you can have same radius by changing B. That is called a synchrotron. Because if you increase the V, if you have a constant magnetic field, you know R increases. Cyclotron R increases. We are using the cyclotron, not in synchrotron, no other thing. But in a synchrotron, maybe you have heard about that word, as V speeds, as V increases, you go with the V also increases. So you can keep same radius. So that particle goes around the same radius, it won't change the radius, it's called the synchrotron. Anyway, those are again developments after this. So this is animation, you can see on this, you have alternative electric field. So positive, negative polarity should change as you go along the time. But if things it is a constant, there is no issue at all. So charged particles get energized once it crosses the gap, not within the disk, because there is no magnetic field, can't change the force is towards the center, so it won't change the speed. So this is simple behind. Now, when I went and checked I didn't know about this principle behind it is called the Warburg effect. Hopefully I pronounce it correctly. Where malignant cells have a much higher rate of glucose metabolism than normal cells to fuel their rapid growth. Right? Now there's something important happens here. Now you know we are injecting FDG, not really the glucose molecule. One OH is replaced by fluorine. So at the beginning, the body does not know. You know, our body, our cells does not know whether nuclei is stable or radioactive. We have no way of detecting it. So we have positives and negatives for that. Otherwise, you can't inject these things because our body does not know whether this nucleus is radioactive or not. Because our body mechanisms are all biological and chemical reactions. Radioactivity is a nuclear thing. So in biology and chemistry, nuclei just idle life. Right? All the electrons are taking part of all the other biological and chemical reactions. So whether substance is, whether the molecule or whether atom is radioactive or not, our body does not know. So that is also helpful in order to diagnose these things. Otherwise, if the body rejects, then you can't diagnose, you can't detect. But so at the beginning, this so-called this FDG is absorbed, but there is an enzyme called hexokinase. Hopefully, I pronounce it correctly. Hexokinase that converts FDG into energy. So while doing so, this hexokinase finds that there is some rubbish in the glucose. There is fluorine there. Not the OH part, there is some fluorine there. So then he stops the metabolism. Therefore, this FDG is get trapped inside the cell. So that is also very important. But once it gets trapped, it emits annihilate and it is gone. At the beginning, he does not know. He takes the glucose and get it. And at the time of metabolism, this enzyme, see how marvelous our body is. Then he realizes, he or she realizes this glucose has something else. So it's not the so therefore it allows earlier diagnosis, more accurate staging. You know these PET scans are very, very important for earlier diagnosis of cancer. And if you get the cancer, there are something called staging. That's different stages. You have to get PET scans to find out whether the drugs are working. And effective monitoring of the treatment, whether the cancer has spread and all these things. So hopefully because of this, these PET scanners actually you can get it. It's not because the glucose is not toxic unless you are diabetic. Right? So unless other some radioactive drugs, you can get side effects. Because you can get allergies. So glucose normally I don't know whether you get allergies or not. So therefore, even if you are a person, if you think that you don't have a cancer, we don't know. So you can get a PET scanner and find out if you have some issue of problem. So when I went through this literature, I found that PET scanners are most common used in cancer. Even you can use it for heart problems. Now, in Sri Lanka, still we don't use them. So cardiologists, now some countries, they use the FDG even for cardiac things. Right? So once this drug is available, cardiologists might go for this because if you don't have this drug, then no point of doing. So even brain disorders, central nervous system. So there are even PET scanners are used to some developed countries. They use for Alzheimer's disease, depression, epilepsy, head trauma, Parkinson's disease. Because this glucose is actually all cells like glucose. So therefore, they absorb it, and if there is something wrong, we can detect it very easily. So these are the stages. Seeing if cancer has spread, seeing if the cancer treatment is working, checking for a cancer recurrence. This is also important. Now, normally in Sri Lanka, once we get something only, we go to see a doctor. So always diagnosis much more better than cure. So even if you have a cancer, sometimes that organ or whatever, maybe you have cured, but it has spread to other places. So all these things you can detect it using a PET scanner. Now, apart from FTG, now at the beginning, we are opening this this facility coming Monday, 16th, we are opening it. But the first doses will be delivered in end of March or April because they are test. You can't just inject drugs into people. You have to sterilize. There are a lot of chemical processes and biotechnical processes that has to be done. So, but we go with FTG first. But we have plans to produce this gallium also. Now, gallium is become very popular, especially in direct production for petroleum because gallium also emits beta classes. If there are beta classes, we should detect. And so we hope to maybe after several months, because gallium is not used in Sri Lanka. If you want to get a gallium scan, you have to go to India. So they go prostate gland. As males, I don't know, females don't have prostate glands. I don't know the reasons, but males have prostate glands. So once you become getting old, even my prostate gland is now very large. So it's not cancerous yet, but so we don't know. So this gallium, somehow I went through the literature, the FDG uptake of prostate gland is low. So gallium is very good. There are some organs like some isotopes more than the other. So that's why scientists and doctors are using these isotopes to detect. So gallium becomes even useful in to check other diseases as well. But only thing is it's a solid target. Now we are starting with liquid target, water. But now I heard there's even a method developed, even gallium, you can have a hybrid method, it becomes a solvent. When you become a solvent, it's easy for chemical processes. The chromatography and other things works nicely. So there are some places actually. There is one guy, a Portugal guy, actually he came to Sri Lanka 2 years back. His name is Francisco Almeida. His wife is a Pereira. So once he landed to Sri Lanka, he said, "I landed to Capricorn." So he was very fond of Sri Lanka. He is the one who he developed the first PET scanner in Portugal. Otherwise, we had to get it from Spain. Now we have become a millionaire. He is ready to help us, even without any charge. So he likes to help. He says even in the grade 1 book, to start in Sri Lanka, in Portugal. Our grade 1 books have other things, but so even hopefully we can produce iodine 123 also. Now iodine 131 is used for thyroid gland. Even iodine 131 you have to get it from Germany at the moment, because to make iodine 131 you need a research reactor. But even scientists have found out, even using the cyclotron, you can produce iodine 123. So these are some of the advances. So you all these students can cooperate. We are developing a research wing also that place, so that you can you can come and visit them, you can do your research as well. Because there are 4 beam lines in the cyclotron. At the moment we are using only 1 beam line. So 1 beam line is dedicated for research purposes as well. Because this is a nice culmination, amalgamation of physics, chemistry, biology, biotechnology, everything is there. So these are future. Okay, now here also I copied it from internet. Now the trend is you go with PET-CT both at the same time. We are getting a PET-CT to the King's Hospital. You know this, that is the advantage of working with this private sector. Well, of course, they go for profit. That's good. I think our country, I mean, we have a lot of reasons, we say corruption and everything. අපේ රාජ්‍ය ආයතන බම්පරෝ. Because we are not profitable organization. I learned from that, you have to get profit. There's nothing wrong in getting profit. Right? Isn't it? I mean, otherwise the private sector won't dump their own money. So they have all plans. Right? If you do it with the government sector, you can go home. Now, for example, if I open this facility in the government sector, you have to hire about 20 people. They work with only 8 people. And he wanted to hire a cyclotron operator. Now, we couldn't find anybody in Sri Lanka because there's nobody. So we had to get one from Bangladesh. He has worked in Kenya and others. His salary is $5,000 per month in board and lodging. Government you can't do $5,000. I have to go to jail. Right? So hopefully we can train some cyclotron operators, because this access group is planning to have another cyclotron in UAE, United Arab. So they have all the plans. They always, that's a nice way of some people now, even when I started this project, some of my even atomic energy people opposed it. Because somehow we have this mentality, not all. Working with private sector is very good. Right? But if you are getting economic, so I think nothing to economic, nothing to conduct, right? So somehow the people have changed the view because of this crisis, economic crisis. Some people still believe everything has to be done by the government. No private sector. That won't work. So to develop the country, we have to get help. Of course, we have to give our knowledge and know-how. They will do the job. So even they are planning to export these FTQ to Maldives. That's why they have built up this cyclotron facility near the airport, 10 minutes from the airport. So you see, you see the future. In government sector, we don't see the future. We just go in and go home and sleep. Anyway, so one PT And the advantage of accessible is they are the GE agent in Sri Lanka. So the cyclotron is a GE product, and even PET scanners are GE. So I think they are giving another PET scanner, PET CT, and it will be housed in King's Hospital. Right? So this is the PET scan. Sorry, I always push that. This is the PET scan. This is the CT. So this is PET plus CT. Even my son told me, okay, now they go for always PET CT. He must have room for that. So this there's some problem here, you know. So you get the background, so its contrast is very high. So you can find out where the problems are. So now they go for PET and CT. Problem I should finish. So I just show you some building construction approach. So here this is the bunker for the cyclotron. How cyclotron is housed here. So it's a peak wall, you know. We have to now these neutrons, count neutrons are coming in this reaction. So we have to get rid of the neutrons. They should not reach the outside. So we have these walls are 2.5 meters thick. The GE said 2.1 is enough, but we went for 2.5. The access also good, no, they have the construction also. When these are the normal maze, 6 at part for a bunker, you know, if some radiation or neutron comes, they get scattered and it won't reach outside. So that's a maze for the 6 at part. So even when you want to enter, you have to go like this. So this is where the cyclotron is housed. This is why the cyclotron installed. Actually, we had a hole on the roof, so using a crane, it got landed onto the ground. This is now this is closed. The whole of the. So this is a simple cyclotron. It's not a big thing. These are the 2 points. And these are the D. You know, cyclotron volt, these are all recommended. You have to have negative pressure. The pressure also, we have to have negative pressure because you can understand the reason if the radioactive material it won't go outside. So we have about 20 to 50 minus lower than the normal atmospheric pressure. Hot cells, we have to have this much holding with the other. So nothing gets killed. Of course, even some of these radioactive, all the other materials that they are not very long life materials they are making. There is something called decay and delay method. If you wait for some time, or get decayed. Or even if you have some residuals, waste management, you know, Atomic Energy Board has a waste disposal place. We don't say the place, but there's a place for radioactive materials to get dumped safely and soundly. It is connected to the army camp also. If there's something happens, the alarm goes off. Because normally we get a lot of things from the hospitals. We have a lot of radium, huge surplus of radium, because radium was used initially in the hospitals for cancer therapy. Then they went for cobalt. Now the whole level of the world is advising not to go for cobalt, go with linear cobalt. So because people have worried about if you get this radioactive material, you can make dirty bombs. Dirty bombs is normal bombs, you incorporate radioactive materials also, it's not a nuclear bomb into that. So somehow about 2 years back when I was the chairman, I had some discussion in Canada. Canadian took all the radium that we had. So it was a great plus point for us without any charge, because they can make radium to actinium. Radium has a very long half-life, 1600 years. Then you can convert them in reactors and cyclotrons. Actinium has about some few days. So they use actinium for targeted cancer therapy. Because actinium is also alpha emitter. Radium is also alpha emitter, but nobody inject radium into your body. because the half-life is 1,600 years. You know, in early watches, we had radium, small amount of radium, so you get luminous effect. Now they are banned. Alpha particle range, you know, it won't travel much. So now they are saying called targeted therapy. Now they put small alpha emitter to the cancer rather than getting gamma rays from outside. Because when you go to Apeksha hospital, mentally you are down. Always, oh, I have to get this treatment, these people. But if someone injects something and they are happy at home, mentally you are safe, not down. Right? So that's called alpha. Alpha particles are very good in destroying cells because alpha particles are two positive charges and their ranges are small, so they can destroy. So they took all our radium and they want to convert it to actinium. Actinium 225. So the half-life is short. So somehow we got it up. So this is a view of the cyclotron, the bodies. These are some of the lab instruments. You know, you have to have experience in high power control liquid chromatography, dispensers, so all sorts of things. A lot of money. You have very clean rooms, right? So this is lab is oxygen 80. You can see here. H2 so 80 is a part range of the place where you put the heavy water in oxygen 18 ring. So these are some of the hot cells. Which is distinctive kind. So finally, the facility looks like this. Almost all the construction work is finished. So we are ready to go. So official opening is on Monday, but first doses, you know, we have to have visa and now remember I told you now I was wondering, nobody gave me the answer. I was wondering how this glucose molecule fluorine is attached only to second plane, not the other places. Always, this is why I'm tracing it to find out reason. You can do only and then you can take the fluorine, or other way. Why are they going there? Then I realized actually they use at the beginning they use this molecule. This called manoscreen. මේවා කියන්නේ නිසා called precursor. Why it's I don't know. It's called with actile groups. So these are called protective groups. Again, protective groups. This is the leaving group. So leaving group is left and fluorine making is attached. Then you do the hydrolysis and convert this into glucose. You don't use the glucose first. Because then the fluorine will go to the other places as well. There's a lot of chemistry, I think. These are called precursors. It's something like this. If you want to paint something, so if I don't want to paint this part, you put a tape. Then you paint it. Then you remove the tape. So this is like that. We have a protective group and a leaving group. It's called the Manos triflame. So then you do the hydrolysis of the mechanism. You C1, C2, C4, you protect it using acetyl protective like shield that prevent unwanted substitutes. Only C2 group you have the triflame. So high reactive site replaced by this is lot of chemistry if I don't understand. Right? Then final step to hydrolysis it, and then you convert this mannose triflame into Bluetooth. And one more slide right now. We have to do all these things. Before patient care, you have to check the radiochemical purity. Because there can be other radioactive materials. So what people say is your fluorine 19 or FDG should be more than 95%. Of course, you can't have 100%. There can be some other radioactive elements inside. And you have to check pH. Storage testing. That is without any microbial law, whatever, radioactive percentage, radioactive more radiopharmaceutical storage. Endotoxin means even these bacteria can emit, right? Chemistry, they can even dead bacteria. Experiment testing, checking that pharmaceutical products are absolutely no living microorganisms. Because there's a separate lab for QC and QA, quality control and quality assurance. This is of course, radioactivity you can get it from half-life, that is not a big issue. But other things also very important. So even some bacteria, they emit some unwanted toxic stuff. So if you inject into the patient might get other problems. So we have to make sure that everything is 100% perfect before you injecting to patients. Okay, I think that's all that I have. Tell you, chemistry part don't ask me, I don't know. Physics, everything you can, I hope a little bit of physics, but I can answer on that. So it's actually it's an achievement because as I told you, this is a nice project or model. Even International Atomic Energy Agency people like this because they came to Sri Lanka and find out they consider this as a model institution where you got the help from private sector. Now IAG people are also going for private public partnership. So now the trend is like that. Even to develop our country, I think that's my belief. Of course, you can people always say there are a lot of corruption and everything. That is also one reason. But if you get the right public-private partnership, then the country can get flourished. Because they don't have rules. You know how much I spend time on these things to getting approval. You have to get approval from various departments. Private sector, they get it over a week. When I go there, it takes long time. I don't know what they do. But we have met the central CE. ඊළඟට නගර සභාව ප්‍රාදේශීය සභාව attorney general department. How many things you have to licensing and all this is good, but it took long time because of that. So even after signing the agreement, it took long time to get the other approvals. So private sector level, we know how to get it. He can't do it. For a good course, actually. Of course, Sri Lanka is very good for. If you want some character thing, you can do it very easily. But if you want to do a good job, you can do it. People ask so many questions. So, so this will be, I think, even now researchers, that's what I tell them. Now, go with private sector, good private sector people. You can have win-win situation. මේ අපිට කරන්න ඕන මේ ඔපරේටර් එකෙන් ගන්න ඕන $5,000 ඉන්වෙස්ට් දී අප්‍රූව් කරන්න නැහැ නේ ඒකට කරලා අනිත් තාත්තා හරි මොයි රාජන් ගිහින් $5,000 පුලිස් ගානේ වලුම් දී පවුත් දෙක මොනවද doen I met to Sakura he is very happy to be in Sri Lanka because he like Bangladesh he is happy. Okay, so thank you so much for listening to it.
Thank you, Dr. Rosa, for that very illuminating talk. I just have one question.
Yes.
So I have heard that radiation can actually cause cancer, right? And in this case, we are using radiation to detect or diagnose cancer. And based on what you explained, we are producing two gamma rays inside our body, from what I understand. So gamma rays, can it I think, is it harmful for our cells? It can distort our cells and over time can itself cause cancer, right?
The problem is once you have a bacteria, take that risk. So now, if the half-lives are less than 2 hours, it won't be an issue. Of course, now even if you go to health hospital, they use the gamma rays come from bubbles. So you are exposed, even your good cells are getting exposed. But what to do? That's why I told you now there's another country they have ended up injecting alpha emitters into the cancer. Then alpha particles will come out. So I mean, what your patient is ready, but normal to gamma is not doing enough because they are not very high. They got 911 So, but
So small amount of energy and a very low dosage probably.
yeah,
Okay.
per patient, but it depends on their weight also. They measure the weight of the patient according to some relatively divided by kilogram.
Okay.
Since most of the energy from the proton will be converted into heat during the nuclear reaction, how is the cooling system and the heat control system?
You have to have very good system. Since it is a liquid target, it's not that much because liquid can dissipate heat very easily, not like a solid target. But also there are like that coils. So coils also can be radioactive later on. So all these things we have to keep it under safe custody. Of course, if the material is radioactive because material, very short half-life. Like now, for example, in this process, you can make nitrogen 13. So proton can heat on to oxygen 16 also. Then you make nitrogen 13. But nitrogen 13 has a very half-life is several minutes. So it goes in, once you have 5-6 half-lives, activity is all reduced to nothing. So it is true that you have to have very good control. Now you have to have pressure control, you have to have sterility control, clean room, water dispensing, cooling. You have to recycle the water, and time to time you have to check the water also. So all these things can be because technically go to the acute. We have a technical the regulatory council also. They are the ones who are giving license. Correct? Even for X-ray machines, even if you go to a city, some dentist small X-ray machines, you have to get a license. So we have checking the radioactivity. There are doses. So we are very equipped to that. Now I can't say we, but board is equipped to those things. So and this is not the first cyclotron. So I think I don't have time. Even if you go to YouTube, there are a lot of small YouTube presentations from our PET scanner and the treatment facility works. So
And also, sir, is there a need of beam down section for this?
pardon me?
Beam down section.
Because actually to produce the FDG for Sri Lanka, at the moment, if you run this cyclotron for 2 hours per day, that's enough. Because we don't have high capacity. Unless other private sector hospitals bring flex cameras. So 2 hours is enough. So normally what happens is in other countries also you do this in night. They early in the morning and dispatch FDGs to hospital early in the morning. So per day 2 hours is enough. At the current usage of but the private sector people bring flex scanners, then we have to run it little higher. But as I told you, access they are going to have because molecules, molecules don't have any activity board. So all the help they get from Sri Lanka. They don't go to India, they come to Sri Lanka for some reason. If everything goes well, even we can export. Even they have found out even India, the down south parts, sometimes from Sri Lanka is accessibility is less rather than getting from Delhi or Mumbai. So these private sector people, they know how to do business. That's good. I mean, you should not do business if you don't get a profit. No. No. When you are wasting the resource money. So getting a profit is not bad. So not unwanted profit. Yeah. No, this is a small one, it's a medical side. You can say that from the diagram of actual side. It's not a big size.
What's the big achieve to create that?
We go with 18 ME, so we can do a small half of inch. So actually we can use the current is body. 18 ME we don't know, we just have to do half of the swap because 18 ME and convert ME into use. I have not done that. You can find a sleeping. Normal day, now there are several companies who produce cyclotrons. One is D, other one is called IBA. Some countries go for IBA facility, some countries go for DE facility. In China, they have. But companies are very limited. You don't have hundreds of companies who are providing cyclotron because with cyclotron you can have other facilities as well. So GE is very good because GE is a very brand product.
Use the cyclotron or increase the speed.
Yeah.
Other options are the other idea to increase the speed. The only option to use cyclotron or is there any other?
No, I mean, as I told you, to increase the velocity of a charge particle, you need to get it through. Even now, over being said, not the LED, the cathode ray, so small accelerator. Filament from filament, you get electron, you increase the speed. By applying the magnetic field, you can't change the speed of the direction like when I say, not it's two but the temperature goes in a field. So if you want to increase the speed, you have to apply a electric field. So the magnetic field is there to conform to charge path. Otherwise they will go here and there. So magnetic fields are there to sustain the charge path. Electric fields you need to pump energy. So once we cross the gap, you have to give a kick. Okay, thank you so much.
Thank you very much, Professor Rosa, for that insightful and enlightening presentation. Your talk has given us deeper understanding of how advanced physics research directly impacts medical technology and cancer diagnosis in Sri Lanka. As a token of our appreciation, we would like to present the small souvenir to our guest speaker on behalf of the Physics Society. I kindly invite Dr. Manko Madhavi and Professor Vinod Fernando to come forward to present the program of appreciation.